We are going to solve a c242 sample test 1 NMR problem. We have a molecule with a formula C24H36F2O4 giving an intense infrared absorption at 1732 reciprocal centimeters, having a proton decoupled C13 spectrum with 11 signals. The most important data is over here. It is our proton NMR data. It's always a good idea to start these problems with an analysis of the index of hydrogen deficiency. We have a formula of C24H36F2O4, which corrects to this formula here, C24H38. Fluorines replace hydrogens, so we add 2 H's and we ignore oxygens. The reference molecule with C24 is H24 plus 2 plus 24 times 2 plus 2 is 50. Subtracting, you get 12H difference, divide by 2, an IHD of 6. Over in this area here, I see peaks near 7.1. That is definitely indicative of benzene being present. Benzene by itself has an IHD of 4. This is an ortho-disubstituted benzene for this reason. We've got to account for 4 H's, clearly, in benzene, leaving room for only 2 groups. I picked ortho-disubstituted with the same groups because of this fact here. There must be much symmetry from the C13 data and the formula. We have 24 carbons to account for, but only 11 signals. And we're also given this information about infrared absorption. 1732 reciprocal centimeters indicates a carbonyl. So that's 2 more IHD units. We have accounted for all 6 of our IHDs. No more rings, no more pi bonds. Getting back to the substitution pattern being ortho. This H here must be a doublet because it has 1 neighbor. That looks like H here. You might think that this H here would be a triplet, seeing as we have 1 neighbor underneath and 1 neighbor up here. The fact is, you cannot be a neighbor to your identical twin. Burn that into your brain. This H here is identical to this H here by symmetry. So the only way to have 2 doublets on a disubstituted benzene is to have the 2 groups ortho. We're going to analyze A. Keep in mind, whatever I say about A, we are doubling the number of carbons and hydrogens because we have 2 identical A's. I'm looking first at this unique piece of information here. How can you have 12 identical H's? This is the most logical way to have 12 identical H's. 2 identical methyl groups with 1 neighbor. The neighbor being indicated here because a doublet is caused by 1 neighbor. So, we have 4 methyls with the 2A groups that are identical. That gives 12 H's. So why don't we talk about A. A is a doublet. So the next carbon over can have only 1 H. 1 H. Go back to this 1 H here. If A is the only neighbor, then there are 6 AH's. That would give a heptet. Please look for information about a heptet. There. This is very good information. On the left, we have the heptet caused by the 6 neighbors. This says on the right, there are 2 more H's causing a triplet. Let's put those H's on there. We will recolor them. There we go. So I believe this would be B. And these would be, we don't know yet. Okay. We clearly have to continue doing something up here. These two H's have one neighbor. That would be a doublet on one side. I'm looking at B here. I have to apologize. I believe earlier I said this would be C. And I wrote B by mistake. These might be B. They might be other things. But I like the B part because that's one red H causing a doublet. We could have E instead of B, because there's a doublet there. I don't believe these are appropriate because there's no way to have a triplet only. There's only one neighbor on the left. So let's stick with B and see if we can make it work. If it's to be B, then we have a doublet on the left and another doublet here. That would be only one more neighbor here. And we'll color it green. Okay. So, we have a doublet of doublets. This H clearly has two neighbors to the left, which would be a triplet pattern. I'm leaning towards F here because I see a triplet on one side and another triplet on the other side. Let's see if we can make that work. That would be two more H's on the next carbon. And that would be a triplet of triplets. Going back to F here, if I like this for F, then I need to account for the fact that F has such a high shift, 4.4. My two choices of atoms here, based on what's in my formula, are F or O. If I put F there, it works nicely. On my chart it says it should be found between 4.4 and 4.5, and F is. And that's pretty good. Now let's look for this guy. We are running out of hydrogens that are not attached to benzene. Keep that in mind. We haven't accounted for a carbonyl. Keep that in mind. If you're one away from a carbonyl, call it alpha. These two both fit in that category. Of those two, E is the only logical one because there's only one green neighbor, which would cause a doublet. So let's go ahead and attach a carbonyl here. That would make this an ideal candidate for E. I've done a little thinking. Outside of the benzene, we have only two more carbons and one more oxygen. Multiply that by 2 because we have two of these groups. So 4 carbons remaining 2 of them on this A group, and 2 more oxygens, 1 of them on this A group. You could think that maybe this is also alpha, but that would be a CH4 group. We're talking unicorns. Oh, 2 CH2s would be okay. I apologize. But knowing what I know, we have not accounted for this high shift. I look on my chart for candidates involving oxygen, and I see that a carbon attached to an ester having H's on it would have a peak at 4.6. I think I'm going to try an ester here with a CH2. CH2. And we're running out of colors. We can use good old black. Keep it there as it is. Sure. And that could be G. Now there's only 2 more H's coming up. G says I need 2 H's on the neighbor. And there you have it, 2 H's here. Oops. Two H's. Will be a good candidate for this. We need 4 H's because there's duplicates of these. I don't believe I've used D as of yet. Can we make D fit? And I believe the answer is yes, but only if we have something to shift those H's up. To 2.4. DHs are called benzylic, which means they're on a carbon 1 away from benzene, and that fits. And I believe we have the A group here. In summary, we have our AHs here and here. We have our C's here and here. We have our B's here and here. Our F's here and here. G and D. And the benzene, we haven't done H or I. I would pick the ones that have a slightly higher shift to be I, because a carbon is more electronegative than a hydrogen, and that would leave these to be J. This problem is solved, except I need to show this J here. Congratulations, 18 points.